Okay, so this video walks you through how to convert rectangular coordinates to polar coordinates. And this is still connected to section 9.1. So we're going to go to the first problem here. And the problem says the rectangular coordinates of a point are given. Find the polar coordinates r theta of this point with theta expressed in radians. Let r be positive and theta be between negative 2 pi and 2 pi. So our first step is pretty simple. We're thinking of these 2 points in rectangular coordinates. Our x value is negative 3. Whoops. I'll be using a pen, not a circle. X value is negative 3, y value is 0. So we go 3 units to the left, 2, 3, and 0 units up or down. So our point is right here. So now we need to convert this to polar coordinates, and since it's on the x-axis, this is pretty simple. Do that real quick. Okay, so first, let's think about this as positive, with our r value being positive, r has to be positive 3, and if we rotate in the positive direction, we're going to get 3 and pi. What happens if our r is still positive and we rotate in the negative direction? If we rotate in the negative direction, this will be 3 negative pi. So do you see you can have a positive r value and a negative angle? And what if, even though the problem is complete, the answer was actually 3 pi? Because they wanted or 3 negative pi would actually work too, because negative pi is between negative 2 pi and positive 2 pi also. Let's just extend it for a minute. What if we wanted our r value to be negative? If our r value was negative 3, then remember, you would be facing pi, but walking toward, in the opposite, we'd be taking 3 steps away from pi, and walking 3 steps away from pi in the opposite direction would be negative 3 and 0, because we would be walking in that direction. Also, along those same lines, we could call this negative 3 and 2 pi, because 2 pi and 0 are located in the same place. Okay, so that's problem number 1. Problem number 2 is a little bit different because it is not on one of the axes. Problem number 2 says the rectangular coordinates of a point are given. Find the polar coordinates r theta of the point with theta expressed in radians. Let r be positive and theta be between negative 2 pi and 2 pi. This time our x and y values, whoops. Okay, this time our x and y values are negative 4 root 3 and 4. So let's draw our trusty little circle. Kind of fun that it's a actual real circle, not those deflated circles I draw in class. Draw our lines. Okay, so first thing we want to do is place this on the unit circle. Negative 4 root 3 is going to be in the negative x direction. Positive 4 is going to be in the positive y direction. So that's going to put us in quadrant 2. Whoops, we need to draw a line. Okay. So in quadrant 2, we draw our triangle. And then I'll draw it a little bit bigger down here. And we know that our x value is negative 4 root 3 and our y value is 4. So if we want to get our hypotenuse, we use the Pythagorean theorem, so we say 4 squared plus negative 4 root 3 squared equals c squared. 16 plus 16 times 3 equals c squared. So that's 16 plus 48 equals c squared. So 64 is c squared, so c is going to be 8. Okay, so we draw our triangle. Now let's look at this triangle for a second. And hopefully the first thing that stands out to me is that we've got a triangle here with a square root 3 as one of the sides. So I'm really hoping that maybe if we simplify this triangle, maybe we could get this to be a 1, 2 square root 3 triangle, a special triangle. When I see root 3, I think of it as a 30, 60, 90. When I see root 2, I see it as a 45, 45, 90. But we don't know if it's a 30, 60, 90 yet. We need to first, do you see how all three sides of the triangle could be divided by 4? So let's see what happens if we divide all three sides of the triangle by 4. What is our new triangle we get? Let's see, we'll draw it up here. Our new triangle is going to be negative root 3 for the x value, 1 for the y value, and 2 for the r value. And do you see that that does reduce to be a special triangle? That's a 30, 60, 90. And since it's a 30, 60, 90, now we know what that reference angle is. That reference angle right here is 30 degrees, or pi over 6. So now, remember, we're looking for r and theta. R represents the hypotenuse. And r represents the hypotenuse before you reduce. We reduce just to figure out what the actual angle theta was, but the actual r, the actual distance from the origin to the point, is 8 units. So we want to keep our r value as 8. Our theta value is going to be, with a reference angle of pi over 6 in quadrant 2, we know that pi is 6 pi over 6. So if we've got 6 pi over 6 at pi, then this has to be 5 pi over 6. So our angle theta is 5 pi over 6. And those are our polar coordinates for that section. I hope this helps.